Welcome back, everyone. Today we will be discussing RF2, which is representing lines with equations. Our objective today is that you're going to be able to represent lines with equations. The title kind of says it all. First thing, let's start off with a warm-up. It says find the slope and the y-intercept of each linear function. Now, looking at this first one, this might serve as a little bit of a reminder and get the wheels kind of greased a little bit. Remember, when this is in slope-intercept form is always y is equal to mx plus b. And that m represents our slope. So in this situation, we can see that our slope is located right here, 2/5. That will be our slope that we can write right there. Looking at the b value in this problem is the 3. Right? So the 3 is the b, so we can put a 3 right there. Our y-intercept is 3, and we have a slope of 2/5. Not bad. Let's look at the next one. Oh, this one gets a little weird. I knew this was too easy to be true. Looking at this one, our slope is really easily identifiable here. It's this -5/2 that's sitting in front of x, because we know that's where our slope always sits. Because our slope is y, or I'm sorry, our form or equation is y is equal to mx plus b. Now, if I have -5/2, that's my slope. Great, we're halfway there, kind of. We're missing the b part, right? Where did it go? Now, we got to remember, in math, we have different ways of hiding and disguising stuff if we don't see numbers. Remember that in any equation, I could always add 0 to it, and I don't change that equation at all. So this is perfectly legal to do, and what this means is that our b value must actually be 0, right? So it's important to look for those missing numbers. Let's see what else we can do. Let's do the one right below it, number 4 here. This one, I think we got a little bit of a missing number situation too. We can see our b value right away. Remember, it's the number that's added or subtracted to the end here. It's that 5. That's your b. The issue is our slope in this one. It's gone. Now, if you look at this one and you're thinking to yourself, okay, well, how could I disguise it? Remember, your slope has to be the number in front of x. Right now, the only thing in front of x is that negative sign. So, if we think to ourselves, well, what number could fit between the negative and that x? If we zoom in really, really closely, pinkish looking 1 kind of appears. This is -1x there, and that -1 is actually what your slope is represented by. Let's go to the one below that. Look at this thing. They have hid about everything that they possibly could on this problem. Now, we got to get creative when we see this, okay? Now, actually, this is a special kind of line. It's one of those horizontal lines, but I'm just giving that on the little hush-hush here. We'll talk more about vertical and horizontal lines, but this one's special. Now, we don't see an x anymore. Remember that anytime an x disappeared, it must have been like multiplied by a 0. So we could really rewrite this and say that y must be equal to 0x. And then since that 1 is positive, I could say plus 1. This would take care of the fact that I don't see an x anymore. Because once I see that this is 0x, I know that this would be 0. And 0 plus 1 just becomes 1. So this simplifies too darn easy, and that actually makes some sense. So our slope in this problem must actually be 0. Whereas our y-intercept, our b value, must actually be this 1. And you can maybe see that a little bit easier in this one right there. It's that plus 1 at the end. Let's move to the left of that, number 5 here. Looking at number 5, finally a normal one again. Our slope in this one is this -4, and our y-intercept, our b value, is this -1 up there. Remember, it doesn't always have to be a plus. If it's a minus, that means there's a negative that goes in front here. Oh, last problem. This one is tricky, guys. This one, let me tell you about this one. This one is actually a vertical line. You wouldn't know this yet, and that's okay, but we're going to discuss it briefly right now. Anytime we have something, do you notice how all of these other ones were y is equal to, 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 except for this one. This one is x is equal to. That's our key indicator that this must be a vertical line. It makes it weird. Now, what's going to happen with this line is that every x value is going to have the value of a -4. So, our vertical line is actually going through -4. Now, if we have a straight up and down line, we remember our slope is actually undefined. We got to write the word there. That's why we don't see it up here, because we don't normally see words mixed in with equations. It's undefined. And our b value, remember, our b value is where our line crosses the y-axis. Now on this one, we can see that they don't cross because they're parallel, right? They won't ever cross. So in this situation, maybe we'll say there is none. We'll talk more about those as we go. They're tricky, I get it. But for 1, 2, 4, 5, and 6, you should be pretty good at those, I think. I hope. Let's talk about where we're headed today, ladies and gentlemen. Today, I'm going to give you an equation, and I'm going to want you to graph that equation and to make me a table of values. Now, we can do a lot of stuff a couple different ways here. So let's just try to tackle them as we go. I think we got 3 problems to look at. First thing we should realize is that in this equation, this is written in slope-intercept form. Remember, in slope-intercept form, my slope sits right in front of the x, and the b value, or my y-intercept, is the part that's added or subtracted. So we can quickly come over here and identify our slope to be 7/2, and our b value to be a -2. Now, at this point, it turns out we can actually graph our equation. If I know I have a b value of a -2, that means I have a point right there. And now, instead of using the line to find our slope, we're going to use our slope to graph the line. Here's what I mean. If you remember with your slope, it's always your rise over your run. So if I have 7/2, what that means is that my next point must be up 1, 2, 3, 4, 5, 6, 7, and over 2. So it looks like we'll have a point at the coordinate 2, 5. So at the point 2, 5, I will get another point. Good. Let's keep going with that for a second. Okay, so if I went up another 7/2, so 1, 2, 3, 4, 5, I can't even get up 7, otherwise I'm going off my graph, and that's not okay, we know that. So instead of going up 7 and to the right 2, remember, we can go down 7, 3, 4, 5, 6, 7, and left 2. And that is actually okay as well. Now, you know you did everything correct as long as, and this is important, guys, as long as that when you connect these dots here, it has to be a perfectly straight line, which means a line like I have right here would not be good enough. You need to have something that is nice and perfectly straight like that is. Oh my gosh, it's perfect. So that you can sit there and see exactly where you're going. Now, the last part of what we're doing today, this is it, is you just need to sit there and make a table for this. So to make a table, we're just going to use the points that we know the graph goes through. That was the point, what? 2, 5. The x always comes before the y, so 2, 5. And we're just going to make a value. Down here, when we get to this point, the x value of that point was 0, and the y value was -2. So I get 0, -2. And last but not least over here, it looks like we had an x value of a -2, and we had a y value of a -9. So we would be able to say that our point is -2, -9. Very nice job. Now, if you notice, there's still a couple extra spots on the table. If you know of any other points that it for sure goes through, you can graph those, or you can label those or put them down. But for right now, those were the only 3 points that we were able to identify on our graph, which means that's good enough. Now, just as a quick description of our graph, I would say a good description of this graph would be a line with positive slope. Let's take a look at another one, right? Before we do though, let's just summarize. Where did we start? We started by finding the slope and the y-intercept of our graph, and we wrote those over here. Now, in order to graph that, what we did is we said, okay, if I know my b value is a -2, then I can start right over here. And then I just used my slope to figure out where my next points were going to lie. So since my slope was 7/2, I went up 7 and over 2. And when I say over, I always mean to the right. And then after we found out that our next point was going to be off the graph, we said, okay, well, let's go down 7 and back 2 because that's the same thing too, right? To get your table, just find the points that your graph goes through and then give me a quick description. Here's another one for you. Again, this thing is in slope-intercept form. Y is equal to mx plus b. So our b value is pretty clear to see. That's going to be 6 here. That came from right here. And our m, our slope, is going to be sitting right over here. So our slope is a -2/5. Okay, great. So let's go to our graph now and try to graph that. You always want to start wherever your y-intercept is. So that was our b value of 6. So up here, we can come and put our first point. Now, from there, we're going to use our slope to tell us where to go next. So looking at our slope of a -2/5, that would tell us to go down 2 and to the right 5. So if I go down 2 and to the right 5, 1, 2, 1, 2, 3, 4, 5, this would be my new point. It looks like that has the coordinate of 5, 4. Now again, let's try to follow that pattern and see if we get another point. If I go down 2, 1, 2, and over 5, 1, 2, 3, 4, 5, we get another point. Now, just to ensure that our graph is looking nice and clean and pretty, we should always try to find points in both directions. Now remember, the opposite of going down 2 and to the right 5 would be to go up 2 and to the left 5. And we can see that that works too. If I started at a point on the right, and this only works in reverse, so you always got to start at a point on the right and go to the left. If I went up 2 and back 5, I would hit another point. Up 2, back 5, I would hit another point. Up 2, back 5, I'm going to hit another point right there. Up 2, back 5, 1, 2, 3, 4, I did get 5. I'm going to hit another point right there. And again, connecting those with the straightest, the prettiest, most beautiful line you can. You got a line, guys. Great job. Now, at that point, we just need to fill out our table. Remember, our table are just the values of the points we go through. So starting over here, it looks like that point would have an x value of a +10, and it would have a y value of a +10 as well. So this would be the point 10, 10. Oops, wrong one. 10, 10. Nice. Let's go to the next point. So we've already done this one. So now let's tackle this one. So looking at this next point, it looks like this one would have the x value of a -5, and it would have the y value of a +8. So -5, +8 would be our coordinate. Going to our next one. Hey, our next one's just our y-intercept. So we just need to think a little bit cleverly about this. We know that our y-intercept is already on x equals 0, and the y value just happened at 6. So I know that I would also get the point 0, 6 here. Looking at my next two, for that point right there, when we trace out this, we would have our x value at 5 and our y value at 4. So 5, 4 would be our coordinate. And last but not least, for our last point, we'd end up at 10, 2. Now, for a description of that graph, we can see that it's a line. So we want to say a line with, well, hold on. Does this have negative or positive slope? If I start up here on the left, right, I always start on the left to look at slope, and I am going downhill as I work across, meaning this has negative slope. Great job. Let's do one more quick. Here it is. Ready? Uh-oh. Here's that missing value again. We saw this in the warm-up. Let's see if we can remember what to do. Remember, it looks like we have the slope here, so that's good. We can put our 1/2 in right there. But it looks like what we're missing is our y-intercept, or b value. Now, to get that b value, we just got to think, well, what could I add or subtract that wouldn't change anything? And hopefully, without too much thought, we come up with, it must be 0. So I'm going to say 0 right there, right? Because if I added 0, we know it doesn't change anything. If I had a plus 0, we know we could just drop that off, and that wouldn't make much of a difference for us. So it must be 0. So coming over here to graph this thing, we want to start our graph at 0 on the y-axis. And then our slope is telling us to go up 1 over 2. When I say over, I mean to the right. Up 1 over 2. There's my next point, my next point, my next point, my next point, my next point. Great job. Over here, opposite of going up 1 and to the right 2 would be to go down 1 and left 2, right? So I'm just following that same pattern, but in reverse now. I want to connect it with a nice straight line. Wow. We are doing great, guys. We're already onto the table. Looking at the table, we just want to identify some points. So I'm going to grab this one, this one, this one, and this one. Try to grab what's happening kind of at the middle of my graph if I have too many points to graph. Looking at the first point, again, look at the x-coordinate, it would be a -4. Look at the y-coordinate, it would be a -2. So our first point is going to be a -4, -2. Our next point appears to be at -2, -1. Our y-intercept is right at the origin, so that's at 0, 0. And then it looks like we are at 2, 1 and 4, 2. Great. We've completed those 4 pieces very easily. Let's just talk about the description of the graph. Again, we see that this is a line, and we want to say with. Hold on. What kind of slope do we got? Start at the left. Always start at the left to look at your slope. It looks like we are going uphill. So this must have positive slope. Awesome. Great job. Thanks for watching. I hope this wasn't too bad for you. If you have questions, though, please make sure you're reaching out. Have a great day.